Swayam Prabha. Digital India. Educated India.
Start, sir.
Welcome, friends, to this live session of the NPTEL online certification course of environment soil chemistry. And in this live session, we are going to discuss several questions which you have already asked. So we are at the end of our course, and we have discussed all the details of this course in our lectures. So basically in this live session, there will be an opportunity for you guys to participate, and there should be, you can ask me some questions, which I'll be, I'll try to give you some answers for these questions. Now, this live session, I'll try to address some of the issues which you raised in the course forum, and also we'll be discussing some of the common question which you guys have asked. Um, this topic topics of today's discussion uh, is basically, I have divided into three major parts. First of all, we'll be discussing the questions asked in the shared Google Sheet. Some of you have already asked some questions. And also, I'll be discussing the questions asked in the forum of this course. And finally, we'll be discussing about the final exams pattern, and what type of questions you can expect in your final exams. Okay. So in a nutshell, these three, these are the major topics of today's live session. And as you have already know that we have divided our course into these 12 week, and each of week have addressed some important aspect of environmental soil chemistry. We started with the evolution of soil chemistry, how the soil chemistry, environmental soil chemistry evolved. And then in the second week, we have discussed about the different inorganic soil components. We have discussed about Pauling's rule and how they impact the structure of different mineral particles, especially clay minerals. And we have discussed different important clay minerals, their structural properties, and how they impact different types of soil properties. We have also discussed. In the third week, we have discussed the chemistry of soil organic matter, and we have seen how these humus, which is a very important fraction of soil organic matter, how they impact soil physical, chemical, and biological properties. And also, we have discussed what are the pathways of humus formation, what are the properties of humus, what are the structure of 3D structure, 2D structure of humus, we have discussed, and why humus properties are intricate and complex to comprehend, we have discussed. Then in the week 4, we have discussed soil solution, solid phase equilibria, and sorption in soils. And week 5, we have discussed ion exchange processes. Week 6, we focused on kinetics of soil chemical process, zero order reaction, first order reaction, second order reaction, and so on and so forth, and how they are involved in different chemical reactions which are occurring in the soil. So all these things we have discussed in details. And then week 7, we have focused on redox chemistry of soils, and we have discussed how these redox reactions influence the speciation of different elements which are present in the soils. And then we have discussed in the next week 8, we have discussed about the soil pollutants. What are the different types of inorganic pollutants? What are different types of organic pollutants? How they pollute soils and what are their specific properties? We have all discussed. And in the week 9, we have discussed about pollutant soil solution interactions. And then week 10, we have we have talked about the retention of pollutants on and within the soil solid phases. And in week 11, we have talked about modeling the fate of pollutants in the soil, the risk and remedies. And finally, in week 12, we have discussed about the analytical techniques of assessing soil pollution. In the week 12, in the analytical technique of assessing soil pollution, I have showed you the traditional ways and also the most standardized technologies which we generally use for measurement of soil pollutants, and also different types of elements, inorganic elements and organic pollutants, also petroleum hydrocarbons. So we have discussed them in details. So when I devised this course, my idea was to incorporate some of the important points which are not generally covered in traditional courses of soil science. Especially in the traditional courses of soil science, you will see that the soil pollution is not generally included. In the introductory soil science courses, this specific topic is not included. Even in the advanced course, they do not very much focus on soil pollution. So this course will prepare yourself to be able to see the soil as a natural body, and also how to how to manage the soil from the and to minimize the soil pollution. You will have an idea. So I have seen that one question as by Arfa Shams, and which part of to focus more in the exam, and also what are the chances of assignment question to be asked in the final exam. Arfa, I'll give you this answer in details. Please, stay tuned. We'll be discussing all this in this forum, in this live session. Okay. So Uh, let me first address one question asked in the Google spreadsheet that asked by Alexi Maria, that could you please tell about the question pattern of the final exam, and is there any job opportunities for the course other than expanding knowledge in concerned subject? If there, can you please share it with us? Thank you. So Alexi, it is a very good question, and I'll try to answer this question in different parts. So you have asked several parts question, and I'll try to give you answers in different parts. So the first part I would like to discuss, that is what are the job opportunities if you have taken this course. So as far as the job is concerned, traditional if you want to be a traditional soil science job, this course will help you to obviously gain something extra which traditional soil science course doesn't give. So there is a huge requirement of soil scientists in different agro-based industries. You'll see nowadays, because they are trying to maintain big farms. So they also want to increase the productivity of their farm by judicious application of different farm inputs, and side by side they are also concerned about the soil pollution. So you will see there are plenty of soil scientist job in different agro-based companies. So if you are interested and if you have taken this course, this will give you an edge in this kind of jobs. Secondly, there are soil chemist positions in government agricultural departments. So these government agricultural departments have their own agriculture, specific laboratories of soils. So there, as a soil chemist, you can join, and obviously this course will help you there for identification of different soil properties, and not only measurement of soil properties, but also since we have covered all the standard methodologies of soil analysis along with the soil these instruments, you will have a better understanding of how to operate those instruments for soil science laboratory. Apart from that, obviously, uh, academic jobs in the universities and government organizations, obviously you can obviously go with the academic jobs in universities and government organizations. You could be a farm manager. Yes, you could be a very good farm manager if you have this knowledge of this course. And environmental analysis in government pollution control boards. So there are environmental analyst positions in different government pollution control boards. So you can join as an environmental analyst. And also there are positions for lab and field chemist. So you are eligible for those type of positions also if you have gone through this course. And finally, there are plenty of academic jobs in environmental science. So you see, there are plenty of opportunity in the field of natural resource management or environmental soil science. It is a relatively new discipline, but the potential is very, very huge. The opportunity is very huge. So you will have a wide range of opportunities starting from different agro-based industries, different academic jobs, and also different government jobs. So you will also, whatever I have discussed in this, it will help you to gain a more deeper understanding of, soil, which you generally do not get in traditional soil science courses. So obviously, yes, I would say that there is opportunity for different jobs if you take the course. So Shilpa has asked one question. Um, with the knowledge, of course, can we start up soil water testing lab? Obviously, Shilpa, because I have discussed about the important, analytical techniques for soil and water testing. I have discussed about all the advanced instruments which you can see in the traditional soil testing lab, like atomic absorption spectrophotometry, like ICP, like GC, like HPLC, and I have discussed their principle in brief. So these will help you to understand the principle of those instruments. And yes, if you really want to build up a soil testing laboratory, I would recommend you to go through this course, obviously, and also the introductory course, which is also available in the YouTube, that is Soil Science and Technology. Please go through that course. You will have a better understanding of what are the soil testing, because in this course I haven't focused much on soil testing. But if you take that course, if you go through these YouTube videos of soil science and technology, which I offered in the last session, you will have a better idea about how to do the soil testing in the lab. And then you can obviously contact me. I will give you a detailed guideline of how to set up a soil testing laboratory, because setting up a soil testing laboratory is also required some other knowledges which are not covered in these two courses, but due to time shortage. But yes, if you are really interested to set up a soil testing laboratory, this information will be hugely important. But some other information is also needed, and I'll be more than happy to share those information with you if you are really interested. Okay, so the second question you asked, what are the requirements and procedure? Any guidance can be provided? Yes, obviously. IIT Kharagpur soil science department, soil science discipline can provide, all these details, information and detailed guidelines. We generally give these guidelines to the farmers and rural entrepreneurs who want to develop these soil testing laboratories in their field. And recently we have started the Agricultural Business Incubation Center with the funding of National Bank of Rural and NABARD, that is the National uh, Bank of which gives the credit for different agricultural purposes. So obviously we have a setup for discussing, and I'll be more than happy to give you this information if you are really interested. And we give some periodical trainings also, and we are planning to give some periodical trainings for those aspirants who want to develop these soil testing labs. So please stay in contact, and we can give you some related information. Okay. So I have answered the first question of Alexi, the jobs. The second question is, okay, the question patterns, and this question has been asked by several people. So I have answered this question. So Arfa has asked the same question. So and all question will be MCQ, multiple choice type of question, and there will be mainly three types of question. One is as a mainly three types of questions. Assignment, the questions which will be asked from the assignments. Questions will be asked from recall, and some open questions will be there. What they mean, we'll discuss in the next slide. Okay. Now remember that each question will carry 2 marks, and obviously some numerical questions will be also there, because in different chapters or different weeks we have discussed and we have solved some numerical problems. So those type of numerical problems also will be there in the test. Okay. So next question is what you actually mean by this assignment, recall, and open type of question. Okay. So recall means question based on recall from the video lectures, video lessons which have already created. So if you have followed those video lectures, these recall questions will come from these video lectures. Okay. Assignment questions are the question based on assignment. So whatever assignments in 12 weeks we have given to you, these questions will be similar to those type of questions. Okay, but with different set of numbers. The open questions are questions that test the candidate's understanding of the concept to differentiate the students. So this question will be also from the parts which I've already covered, and but it will require some better understanding. If you have really understand the concept, you can answer these questions. Okay. So irrespective of whether the questions are recall type, assignment type, and open type, please remember that if you have gone through the PPT and video, you will be able to answer all the questions. Okay. So there should not be any problem. Okay. So whether it is a recall type question, whether it is an assignment type of question, whether it is an open question, all these question will be coming from the PPT and the video lectures which I have already given. Okay. So so all the questions like 3 hours duration which you will face will come on all these MCQ type questions, and total there will be 50 questions. Okay, you have to answer 50 questions. Each questions will carry 2 marks, and numerical questions are there. So be prepared to solve some numerical problems during the exam time. Okay. Okay, so I have seen these are the questions which are generally asked in the asked in the shared Google Sheet. So also Tabinda Saraf have asked which part focus more for the exam, and also what are the chances of assignment questions. I have just answered this question. So just I have answered this question. So is the content available in lecture presentation enough for okay, Karanveer Singh has just asked that is the content available in lecture presentation enough for exam preparation? Okay. And second question is, could foreign university accepts the credits of this course for higher studies such as PhD? Now, Karanveer, I do not know the answer of the second question. You have to, so because each of these, you just have to query it from the NPTEL. I hope, since these credits are, NPTEL credits are accepted by all the standard institution of our country, and this, if they are reflected in your transcripts, obviously they will be given due consideration in the foreign universities. From my experience of foreign universities, I have seen that it doesn't matter whether it has been written in your transcript that you have taken that course or not. If you can satisfy your committee members about your knowledge, then it doesn't matter whether you have taken that course officially or it has been written officially in your transcripts or not. uh, you do not have to repeat the course. That I have, that's I know for sure from my personal experience, because when I did my PhD, when I convinced my when I did my PhD in USA, I convinced some of the aspects to my PhD committee members, which the traditional soil science course will not teach you, and that's why I didn't have to repeat those courses. So obviously, I hope that you have got your answer. But yes, I'm sure that they will consider this thing during the PhD. If you have gained the knowledge, that will be sufficient. But yes, you please make sure and please double check it with your respective department, because the rules changes with the sometimes respective departments. And first question is the content available in the lecture presentation enough for exam preparation? Yes, obviously, 100%. So do not worry. Whatever I have covered in the PPT, if you have gone through those PPT very carefully and minutely, you do not have to worry about it. And all these questions which I have asked are are from this PPT. So do not worry. All questions will be coming from this PPT. All the 12 PPTs which I have covered. Okay. Now, since I have answered all the questions which are asked in in the Google Sheet, okay. So let me discuss some of the important points or which you guys have discussed in the forum. So these topics I'll discuss them one by one. So first question, one question I have seen in the forum, that while heating the soil during the incineration, the soil may get vitrified. So is there any chance of retardation of growth of plants or reduction in soil characteristics? So obviously, because when see, incineration is the thermal treatment what we generally do for to remediate soil which are contaminated with explosives and hazardous waste. Okay, so hazardous waste, particularly chlorinated hydrocarbons, PCBs, and dioxins. So, thus, thermal technologies fill an important niche in petroleum hydrocarbon remediation. But despite these advantages, the high treatment temperature required by most thermal technologies can pose several downsides. First of all, these heating contaminated soil to high temperatures is energy intensive and thus a relatively costly endeavor. So this is the first one. It is a costly thing. Secondly, the soil, mineral and organic matter will be decomposed and may be totally destroyed at high temperature. You know that when we increase the temperature, the organic matter which is present in the soil get destroyed and these get decomposed. So so as a result of that, the potential ability of the soil to support plant growth is very much limited, because it is destroying all the organic matter, which is the major source of major source of this type of nutrients which are in the plant. Uh, when the organic matter is decomposed, it cannot further, it cannot support the plant, because it is limiting the ability to restore soils and ecosystem to their original state. And while it is clear that thermal remediation technologies effectively remove contamination, the impact of high temperature on ecosystem and these regreening efforts are relatively unexplored. So there has been very limited research have been done in this regard. And so regreening efforts, there has been very less information, because most of the time when incineration process was discussed, it was discussed to remediate the soil. But when the organic matter got decomposed and destroyed, how it can be restored to support those plant growth has not been studied extensively. So that is a lacuna, and these are the potential areas of research. Okay. The second question which asked in the forum is why DDT is not yet banned in India even after its negative effects on soil. So over time, despite the international backlash, India has pushed for allowing DDT usage in public spaces to control mosquito plant populations. So much like humans have developed resistance to certain antibiotics over the year, mosquitoes have developed resistance to the certain pesticide used against them. So this is the reason that DDT is not still banned in India. Okay. Uh, so uh, Another question has been asked by Alpha. How much number-wise distribution of questions from all 50 questions will be for recall, assignments, and open? Means the recall how much questions. So Alpha, let me just see. I cannot exactly remember the numbers, but uh, hold on just a minute. I can take a look. Uh, just a minute, I have to see. So there will be total of 50 questions and total 3 hours duration, and all these will be MCQs. Okay. And total, what I can remember, just a minute. Okay, so what I can remember, I'm not exactly 100% sure, but what I can remember, recall that there will be there will be 10 questions from recall, there will be 15 questions from assignments, and there will be 25 questions which are from open category. Okay. So each questions will have 2 marks. So total there will be 50 questions. Okay. Number of questions, yeah, recall category, there will be 10 questions, assignments approximately 15 questions, and open category there will be 25 questions. Okay, so 25, 25, 50 questions will be there. Okay, I hope you have got your answer, Alpha. Okay. Okay, now the another discussion that what is the apical oxygen in the structure of kaolinite. Now this is another very good question. So let me just discuss what is the apical oxygen in the structure of the kaolinite. So if you go back to building blocks for clay minerals, we will see that the silica tetrahedron and aluminum octahedron are the major two building blocks of uh, clay minerals. So silica tetrahedra is basically composed of silica and four oxygen atoms. So see in the middle there is the black dot. So this is silica, which is surrounded by four oxygen atom. So these each oxygen atom has two negative charge, and one of these two negative charge is satisfied by sharing their negative charge with the positive charge of silica, which is 4 plus. So you can see that 4 plus will be neutralized by sharing one negative charge from the surrounding four silicon surrounding from oxygen. But at the same time, all these oxygen will have an excess of negative charge. So this excess of negative charge has to be neutralized or has to be shared in some way. Okay. So how to do that? So you can see these three oxygen atoms are called the basal oxygen of a silica tetrahedral sheet, and this one at the top is called the apical oxygen. So consider that these basal oxygens are shared between two adjacent tetrahedra. So this negative excess of negative charge will be shared with the next with the adjacent tetrahedra, and this excess of negative charge of this oxygen will be shared with another tetrahedra. So all these three basal oxygen will be shared with their adjacent tetrahedra to form a point to point bonding. Okay, now you imagine this as a inverted pyramid type of situation. Okay, so if you go and ultimately when this type of basal oxygens will be joined together, shared together, they will form this point to point bonding and tetrahedral sheet like structure. So this is a silica tetrahedra, and when the silica tetrahedra will join, they will form this sheet like structure. Okay, now this is the total silica tetrahedral sheet. Okay, and another one is the octahedral sheet. And in the octahedral sheet, you know that the aluminium is surrounded by 6 hydroxyl groups forming an octahedron by edge 2, and these aluminum octahedra, individual aluminum octahedron will share their edges to form the edge to edge bonding to form the octahedral sheet. So you can see here this is an individual aluminum or magnesium octahedra where in the center there is an aluminum which is surrounded by 6 hydroxyl ions and forming an octahedral sheet. And if you remember, we have discussed about the Paulink's rule and why these type of structures and what are their coordination numbers we have already discussed in our week 2 of lectures. So please go through these week 2 of lectures to understand how they are forming this type of coordination compound. So please go through the Paulink's rule 1, 2, 3, 4, and then you will have an idea about why they are taking this type of specialized structure. Okay, and finally, when they will join together, they will form these octahedral sheet like structure and these octahedral sheets. So what happened in case of typical soil clay mineral structure, you will see the whole crystal of clay is basically divided into some layers, repeating layers. So this is one repeating, this is one layer, this is another layer. So you can see that one layer is basically composed of either one tetrahedral sheet and one octahedral sheet, or two tetrahedral sheet and one octahedral sheet. So either it will be 1:1 type of bonding or it will be 2:1 type of bonding. In 1:1 type of bonding, the tetrahedral sheet will be joined to the octahedral sheet. And in case of 2:1 type of bonding, the octahedral sheet will be sandwiched in between tetrahedral sheet. Okay. So depending on whether it is a 2:1 type of structure or 1:1 type of structure, you will see the, this stacking arrangement will differ. And the interlayer position between these two layers will be available for absorbing of different types of cations and water. Now you see here in this 2:1 type of structure, how these tetrahedral sheet and octahedral sheet are joined. So you see in the middle, the octahedral sheet, and this octahedral sheet is joined to these two tetrahedral sheet in two sides by sharing their apical oxygen. So you can see this apical oxygen of these inverted silica tetrahedra is basically shared with this adjacent octahedral sheet, and this is how they are joined together. So that is why in this plane you will see both oxygen and hydroxyl are there. So these hydroxyl are these gray balls, and these blue balls are basically the oxygen atoms. So this is how, by sharing these apical oxygen, so this is the apical oxygen, by sharing this apical oxygen, these tetrahedral sheet and octahedral sheet are joined together. And this is how these structural, these coordination structures are generally formed. So this is how these phyllosilicates are generally formed. This is a 1:1 type of structure or kaolinite structure. Now you can see here in the kaolinite structure, you understand that it is an inverted tetrahedral sheet, and the inverted tetrahedral sheet, you see there is a basal oxygen followed by the the silicon cation or silicon plane, followed by again oxygen, which is the hollow balls, and these shaded balls, these are basically hydroxyl. So you can see this aluminum hydroxyl layer is joined with this tetrahedral sheet by the when this oxygen, apical oxygen, is joined between this tetrahedral sheet and octahedral sheet. So this is the structure of the silica this is a structure of 1:1 layer, and this is the structure of the 2:1 type of layer. Okay. So in the 2:1 type of layer, this type of arrangement will be repeated. So this is how these 1:1 type of structure and 2:1 type of structure differs from each other. Now in case of kaolinite, what happens? It is a 1:1 type of structure. So obviously this is the apical oxygen of kaolinite, and this apical oxygen is directly shared with the with the octahedral sheet of the and forming these 1:1 type of structure. And in the kaolinite, there is no isomorphous substitution, and as a result of no isomorphous substitution, the negative charge development is very low. And you see that these are the these are basically the adjacent layers, and in the adjacent layer you can see this is an oxygen plane and this is a hydroxyl plane. As a result of that, this, there is strong hydrogen bonding between these two layers. Okay, so as a result of this, the interlayer space is very much limited in case of kaolinite, only 0.74 nanometer. So this is why the interlayer spacing or d-axis spacing in case of kaolinite is minimum due to the hydrogen bonding. Okay, because there is no isomorphous substitution. Okay, so this is the kaolinite structure. We have already discussed all this. In case of halloysite, they have the similar structure, except one. In the interlayer structure, there is a water molecules are there, and as a result of that, in the electron micrograph, you will see the structure of halloysite as a tubular morphology, because when the water gets dehydrated due to the application of temperature, the hexagonal plate like structure will roll up and form a tube like structure. So this is how you'll see this is why you will see these tube like structures. Okay, now in case of Montmorillonite structure, This is a 2:1 type of structure. AUC again, these apical oxygen. This is an apical oxygen of a silica tetrahedral sheet, and these are also shared with these adjacent octahedral sheet to form this 2:1 type of structure. Okay, and this is the structure of montmorillonite. Remember, the montmorillonite has isomorphous substitution in the octahedral sheet. They develop negative charge, and as a result of the negative charge development in the adjacent layer, there are some repulsion, and as a result of this repulsion, there are molecules. So interlayer space is highest in case of montmorillonite, and as a result of that, you know, uh, the high interlayer space, this type of clay will show high swelling and shrinkage properties. Okay, so montmorillonite, that is why it is show these swelling and shrinkage properties. As you can see, due to the shrinkage, these cracks are opening, and during the monsoon season, when water will move down, they will further swell to and these cracks will not be visible anymore. Okay, so this is the structural properties of montmorillonite. Now, in case of mica, it is also 2:1 type of clay mineral. However, in the interlayer space is occupied by potassium, which are minute in size, and as a result, they are basically non-expanding in nature. And illite is another type of 2:1 type of mineral, and due to the presence of, and in case of illite, the isomorphous substitution occurs in the tetrahedral sheet. As a result of that, uh, you know uh, the interlayer space is occupied by potassium, and which are very small in size, and as a result of that, the d-axis spacing in case of illite is also very low. Okay, so as a result, the illite is also non-expanding in nature. So the illite structure we have already discussed. Please go through these structures, very important for your exam. Okay, do not neglect these. These are very important for your exam. So fine grained mica, how these structures are basically what are the how they are arranged. All these things are very important. In case of illite, you can see these isomorphic substitution are occurring in the tetrahedral sheet, and as it is, and the interlayer space is occupied by potassium ions, which are small in size. Illite, and then vermiculites are also 2:1 type of clay, and they are basically weathered mica products where potassium ions in between the two molecular sheets are replaced by magnesium. So, as in the advanced level of weathering from illite, when these interlayer potassium get replaced by magnesium, then it will convert to vermiculite, dioctahedral vermiculite. Substitution occurs in both the tetrahedral octahedral sheet. And in case of trioctahedral vermiculite, substitution occurs in the tetrahedral sheet, and all three of the octahedral cation positions are filled with magnesium, since it is trioctahedral in nature. And the structure we have also discussed. Chlorite is specialist type of special clay mineral, whether you can see that tetrahedral sheet and 2:1 type of layer, and in between these there are hydroxide sheet, which are basically uh, so basically the chloride can be divided into ditrioctahedral or tritrioctahedral. In case of dioctahedral in the 2:1 layer, and trioctahedral in the interlayer octahedral hydroxide sheet. So remember that this interlayer oxide hydroxide sheet is all most of the times are trioctahedral, so they are dominated by magnesium. So this is a chloride structure. Due to the presence of this interlayer hydroxide sheet of magnesium, they are also non-expanding, and as a result of that, the d-axis spacing is also very low. So we have discussed all these magnesium or aluminum hydroxide sheet, and they are also very much nutrient poor. Remember, in case of chloride, the isomorphous substitution occurs in both the tetrahedral sheet as well as in octahedral sheet. Okay, so if we compare the structures of different clay minerals side by side. You will see this 1:1 type of kaolinite is non-expanding, non-swelling. In case of montmorillonite, it is 2:1 type, and there is highly expanding and maximum swelling. You can see water molecules and miscellaneous cations are present in the interlayer space. And in case of vermiculite, these are expanding, shows some amount of swelling. And in case of illite, they are non-expanding in nature because of the presence of potassium ions in the interlayer space. And in case of chloride, it is 2:1:1, but the interlayer space is totally collapsed by this, or locked by this hydroxide sheet. As a result of that, their DX spacing is also very limited. Okay, so uh, another question was, why north facing soils are wetter and cooler than south facing soils? So in the northern hemisphere, north facing slopes in latitude from about 30 to 50 degrees Celsius receive less direct sunlight than south facing slopes, and the lack of direct sunlight throughout the day, whether in winter or summer, results in north facing slopes being cooler than south facing slopes. The next question is, why agricultural wastes are considered as source for contaminants in water and soil? It is, that agriculture pollution is the main source of pollution in water and lakes, and chemicals from fertilizer and pesticides, when they go to the groundwater and they contaminate the drinking water, they pose severe problems. Health related problems like blue baby syndrome, as you can see in this picture. Blue baby syndrome, it can cause deaths in infants. And some oils and degreasing agents, metals and toxin from farm equipments also cause health problems when they get into drinking water. And fertilizer, manure wastes and ammonia turn into nitrate and phosphates, and they, when they washed into the nearby water bodies, they can create eutrophication. And also bacteria and parasites from animal waste can get into drinking water, producing serious health hazards for various marine life and animals. And as a result of decline of oxygen levels, they cause death of fishes and other animals. And this is the eutrophication of the lake, and we have discussed this in our lectures also. So these are the reason that these agricultural wastes are one of the major source of this type of problem. Okay, excessive use of fertilizers and pesticides combined with other agrochemicals controls the invasive pest, but same time they are also they are destroying the they are very harmful substances, and they can remain in the soil for a long time to destroy the natural microflora or beneficial bacteria. So these are the reason, that's why they are very these agricultural waste products are very important for soil and water pollution. So, guys, I think that I have covered the most of the important things which you have asked in the forum. Also, your questions. Um, Please feel free to email me if you have further questions. I'll be more than happy to guide you if you are interested really to take this opportunity for establishing a soil testing laboratory and take specialized training for soil testing, and also make it as a business venture. I'll be more than happy to help you. My email ID. Please feel free to email me, and I'll be more than happy to answer your queries. I hope that I have also answered your queries regarding the exams in details. So please, prepare accordingly, and I wish you all the best. I wish that all of you will score very good marks in the test, and do not worry. All the questions will be coming from whatever I have covered in this all the 12 PPTs. Okay. So thank you very much for joining us. I also must thank you, my students Shweta and Shagota, who have helped me for these questions, for jotting down these questions, and they also helped me uh, for running this course. And so I again thank you all Shilpa is asked that my email ID. My email ID is, you can see in IIT Kharagpur page. If you type my name, you'll be directed to my page, and you can see my email ID there. But my email ID, you can write it down. It is somsubhra@iitkgp.ac.in. Again, somsubhra@agfe.iitkgp.ac.in. So thank you guys. I hope that you have got some information, useful information, and best of luck for your final exam. Thank you.